toxic algae blooms. Okay, we have algae blooms that are toxic in the sense that the species is toxic to other species, but most toxic algae blooms are actually the ones that create a dead zone. Okay, because the oxygen levels drop to critically low levels known as hypoxia. Okay? And this is linked to events where you have too much nutrients in the surface waters. Okay? Can be near key river systems or so, human-induced, okay, eutrophication or so, but can also be induced by upwelling. Okay, upwelling of nutrients. Doesn't have to be a human-induced process, can be also a natural process. And what happens is, if you create an excessive algae bloom, like the red tides that you can see here over my shoulder, okay, you also induce an excessive bacterial oxidation of detritus. So the bacteria really get lots of work to do. The oxygen levels drop, and they can drop below critical thresholds and create so-called dead zones. Okay. In addition to that, as I just said at the beginning, certain dinoflagellates contain toxins as well. Okay. So this is what we call algae blooms, and it's to do. There is a link to the nutrients, and it depends on the level of nutrients in the water. So how much do you have? If you have too much nutrient in the water, you can create these toxic algae blooms. Indeed, the algae blooms themselves, if they're not too excessive, are good features, okay? Because that's how you create life in the ocean, okay? You create spatially concentrated algae blooms can support spatially concentrated marine food webs. Okay, see lecture on life in the oceans, and indeed we come to the upwelling process in the next lecture. Okay, where you learn more about spatially concentrated marine food webs.